Hayden and Will, hello. Hopefully you're finding this. But what we've done, and lovely ones, just in case you happen to be away, and Daymap did the thing that it did. So in your Teams thing, what I've sort of done is I've put your lessons, and I'll start any videos, I'll just whack it in here now. Okay, and then the notes of the lessons, they can be there, and then I don't have to keep saving. It's a bit of a pain because I'm writing in here, and sometimes I will have to go and flick back to the Inspire because that's just so much quicker because I can't actually cut and paste from my board. I have to go and do it on my device and put it in there. It's a bit of a hassle. So anyway, I'll try and keep stuff in here, or maybe I'll just copy and paste later and stick it in. But this is 6K, question 2. Can anyone want to have a discussion about what's going on here? So discuss the possible solutions of the following systems. K is a real number. Interpret the solutions geometrically. Now, this is when I can have my pointer. Because the people at home can actually see what I'm pointing at now. Before we even do any of this row-up stuff, we should be looking. Can you notice anything about these two equations? Like your numbers, 6. Yes, so 1 times 2 gives you the 2. 2 times 2 gives you the 4. 6 times 2 gives you the 12. So, straight away we know what would be the value for K, without doing any work, whatever, what would be the value for K? -2, that would make it be? Coincident, so infinitely many solutions. Proving it using row ops, right? We get down here and you can see, huzzah! If K equals -2, what happens? Oops, I'll just leave. The bottom row is all 0 and therefore it's coincident. Yeah, that's what we just said. What happens if K is not equal to -2? So you would get 0, 0, I don't know, 5 equals 0. Then Z equals 0, and then you can get a solution, but it will be a line because we would then, for Y, we'd have to go, let Y be T. And so what is that giving us? That's when the two planes, meet in a line. Does that make sense? So obviously we could look at it right from the get-go and go, yeah. When K equals -2, that's why our bottom row is 0, 0, 0, because we could see from looking up here, if that was -2, it's just multiples of each other, so therefore infinitely many solutions. They're coincident. Infinitely many coincident. But if K does not equal -2, then what do we have? 0, 0, K plus 2. All right? And therefore, we would have K plus 2, Z equals 0, therefore Z must be? Yeah? And then we'd go ahead. It's very off-putting that you are continuing to talk. Yeah, but I'm talking to the class. Y equals T, and then you'd get X equals in terms of T, and we know, hey, that is the equation of a line. Capiche? That is going to then extend when you get, if you look down a little bit, then they'll have your 3 equations. But you will still end up with the bottom line sometimes having that. It might have a K on the other side as well, and you go, ooh, when's it going to be? Unique solution, no solution, infinitely many solutions. And it all comes back to what that bottom row is. Agreed? Thank you.